Recording in progress.
Do we have the timestamps for the YouTube videos?
Yes, very good. All of them are updated in this document that we sent to you with the time zones and all the links. Do you recall? It's everything there for all of the features, okay?
Another question, do you have any preference in terms of if we're organizing follow-up meetings, we just organize that ourselves in the next 2 weeks?
I think so. I think it will be a good information maybe for others. If you prefer us to collect it and somehow track that, we can do that. However, exactly, we can use even the touch base that we are going to have right now, then 1 week before the selection meeting, so feel free to use this time.
What I would suggest is for each utility to book their own follow-up
Yes,
meetings, but
so.
eventually there is a central place where we can just go to the startup name and say whoever did the follow-up
Maybe let's
meeting.
use this evaluation dashboard, that could be something that we already.
As long as there is a place, we had that in the past, so as long as there is an Excel file where we can just go there and say, for these 10 startups, yes, we're having a follow-up meeting. I think that would be useful then to share experiences among each other, after having a more in-depth meeting with certain startups.
If we are able to gather this in the evaluation dashboard all together, that could be a very nice thing that we record in the end and go.
So maybe if you can tweak that Excel
I can,
file
yeah.
and then circulate again, that's probably the best.
Yes, I'll just, I think I'll be column or something.
The questions in the evaluation dashboard, do you send them to the startups as they come, or you will send them in a batch?
We will send it all together. We are giving you time, let's say until end of this week. We will send them on Monday morning, okay? Because maybe you will have some questions that appear. And you will compare one solution to another, something will pop up, so we will send it on Monday, okay?
Okay, great. So I have some more to add, and I would appreciate if possible, and perhaps that was your plan already, to get the answers from the questions from the others as well.
Yes, if you are filling out in this dashboard, we are going to collect for each startup a list.
Okay.
Send it to them and ask them to respond until
And you
Tuesday,
will
so
send the
maybe.
answers to all of us.
Yes, and we will gather this as soon as possible, okay?
Good.
Yes.
Can we also have the main contact at each
You
startup?
do,
We have
you
already-
already do, it is always in the database of applications.
Okay.
If you would like this to be,
No, it's okay, so just use like do the application as the first point of contact.
yes, usually it is,
I think we should be talking to the people that did the pitch because they know.
we have this information as well, we can update it in the, well, wherever you want.
Yeah, it's all in the master file, is that which file is the column, the name, email.
Presenting, yes, we have that. Okay, I will have to update. So we will add information about presenter over here with us in the evaluation dashboard, okay, for everyone, in case you would like to contact them. Okay, let's get ready for Energiot. Devices, sorry, and it will be Mary from, Voila. We are right now going into a block of grid planning, optimization and stability. That is a continuation from yesterday. We will do it until the end of today and beginning of tomorrow. Okay? Good, I think we're ready off. And we have you, hello. Hi, and the IoT, Gonzalo and Mary. Great to have you. Welcome, oh yes, sorry. Congratulations on making this to the top 60 and welcome to the pitch event, to the pitch room. We are here, all utilities ready for your presentation. Really excited to meet you and get to know your solution better. We can already see your screen. Start whenever you are ready. You will have 6 minutes for your presentation.
Okay, great, thank you. All right, so we are Energiot, and full disclosure, we first applied to free electrons in 2021. We haven't returned until now, and that's because this year we are primed for success. Since our first application, we have made significant strides advancing our self-powered IoT solutions, collaborating with TSOs and DSOs globally, and validating DLR in real-world conditions. Now we're ready to move forward. Energiot is the right partner for your grid, and our technology is tested, scalable, and already delivering results. So let's dive in. Around this time last year, we were invited to participate in a DLR field test with Red Electrica and several TSOs in Slovenia, including Hydro-Quebec. And Red Electrica was particularly impressed with our device's ability to accurately measure transmission line sag, achieving a relative error of less than 2%, even at high temperatures. And their confidence in our solution led to an even bigger opportunity, as coincidentally, today we have successfully installed one of our devices on a transmission line in Ibiza for Red Electrica. In addition, as a direct result of this field test, we have been invited to participate in 4 ongoing public tenders. And while today we are focusing on dynamic line rating, I wanted to take a moment to highlight that our self-powered IoT technology is already being used for multiple critical applications across the grid. Beyond DLR, we are working with several partners on smart monitoring of substation assets, enabling predictive maintenance, and bird detection and deterrence, preventing electrocution and power outages caused by wildlife interactions. A great example of this is our ongoing collaboration with EDP, where we have a bird detection and deterrence device actively monitoring a critical pole in northern Spain. An Energiot solution is built around a self-powered IoT sensor device designed to provide real-time intelligence for grid operators. Our data can be accessed through the Energiot cloud, seamlessly integrating into SCADA and grid management systems, enabling utilities to make faster data-driven decisions. What sets us apart is our patented piezoelectric energy harvester, which extends operational lifetime and minimizes maintenance requirements, making it a highly cost-effective solution for large-scale deployments. Designed for easy installation and scalability. And this year, we're also expanding our technology to HTLS, high temperature, low sag lines, with a deployment launching in Belgium this spring. So what we are proposing is a 6-month pilot to test dynamic line rating in your grid and show how it can improve your grid capacity. The key goals of this pilot will be to validate real-time line rating and capacity improvements, demonstrate cost savings and lower O&M requirements, provide a clear roadmap for full-scale deployment. And the estimated pilot cost is about 40,000 euros, which includes the installation of 3 self-powered IoT devices, data access and analysis, and a final report with key insights. So dynamic line rating is a fast, cost-effective alternative to traditional grid upgrades. Unlike expensive and time-consuming infrastructure projects, DLR can be rapidly deployed, providing real-time insights on transmission line capacity. This allows utilities to optimize existing infrastructure, increasing capacity by up to 40%, reducing congestion costs and improving grid flexibility. To put this into perspective, we analyzed a real-world example using Hydro-Quebec's transmission network, which spans over 34,000 kilometers of HV lines. And the potential savings from implementing DLR across just 10% of these lines would be approximately 1.2 billion euros compared to the cost of reconductoring. And this calculation only considers the initial investment and does not yet account for the ongoing annual benefits of reduced congestion costs and operational efficiencies. Additionally, Energiot's DLR solution is more cost-effective than the competition. Due to our lightweight materials and innovative design, our device costs less to produce, install, and maintain, making them a financially superior option for large-scale deployment. With Energiot, utilities can increase efficiency, cut costs, and improve grid performance without waiting years for traditional upgrades to materialize. So, thank you all very much, and again for having us today, and we're here to answer any questions if you have them.
Exactly, let's move right away to that.
Hi, Maeve. Fergal here from ESB Books in Ireland. Hope you're keeping well. And well done, good pitch. Before we jump into any particular use cases, I'm interested in understanding a little bit more about the energy harvesting or the power harvesting feature. And in particular, what percentage of your time do the devices or does your device run out of power? And in particular for remote areas where there might be extremes of heat or cold, how does your device stand up?
Yes, well, with me today here is Gonzalo, our CEO, so I'll let him take that question.
Yes. So basically, the energy harvesting unit we are using is based on this piezoelectric technology. So we are harvesting all the time the energy around in the range of the milliwatts, 100 or milliwatts. So then we have the devices acquiring the data and sending the information every 5 minutes. It can be changed actually depending on the current going through the conductor or the temperature of the conductor. This interval can be changed to have like a more granularity or to save energy.
Okay, so there's no risk that the devices will lose power then?
No, wait. Sorry, I didn't understand. I didn't understand your question. To save,
Well, have your devices ever lost power?
And also we have, I mean, the device also have like some supercapacitors and a backup battery. So at any case, even when there is no current going through the conductor, we still have energy in the device. So there is no way to be off.
Okay, cool. And in terms of communication, so the data that your various sensors in your device pick up, how does that data get communicated then back to either your own systems or to the utility systems, whatever way it works? Can you just explain that?
Yeah, so basically in terms of communications, we have the device right now, the new version, we have the device communicating through narrowband IoT to our cloud. It would be also sent directly to the SCADA system from the TSO. But normally what we do is to go through our platform, from our platform to your platform and the platform of the TSO or DSO through a secure channel that we can create to them. Also, sometimes we can install our server in their premises. It's also a model we are using right now.
Okay, thanks. Just looking at your website, you had mentioned that we're up to 15 different types of sensor that you could integrate in your device. And I'm wondering, for the deployments that you've had to date, what mixture of sensors have the system operators felt that were most appropriate to get the best value out of sensor deployment?
Yeah. For instance, for dynamic land rating, the sensors that are more useful are basically the inclination of the conductor, the temperature of the conductor. Actually, we have not only one but 4 different sensors around the conductor. So because the surface temperature can be difficult to measure depending on the type of conductor. And then also we have humidity and ambient humidity and temperature. This is also useful in order to know potential discharges in the line. And but the more useful, I would say, the temperature of the conductor, the inclination, and also the current of going through the conductor.
Okay. And just in terms of your dynamic line rating, with the pilot that Maeve introduced there earlier on. So for a typical, if you could just explain how many sensors you need to deploy for whatever length of line that you're actually trying to assess the DLR on. Can you just explain how many sensors you'd need to deploy on that length of line?
The number of sensors can change depending on, of course, of the type of line, basically where it is located. But normally it's around 3 sensors per kilometer up to 1 sensor every 5 kilometers, depending on the type of line and also of the weather that you have in this specific location.
Okay, and for a typical DLR pilot, how long do you think you'd have to monitor the line to fully understand the baseline and then the impact of temperature on the sag and all this other things that might go on?
Well, actually, in order to start operating, we don't really need a calibration time, but it's true that, for instance, now working with several TSOs, we have sometimes, like in the pilot, time just to validate the interval of confidence. So it could be from 3 months to 6 months normally.
Okay. And in terms of the clients or the customers that you have for your sensors and your devices, is it typically TSOs or do you have DSOs that you're working with?
We have both, yeah, DSOs.
Distribution system operators. Okay, yeah, sorry, yeah, you explained that. Okay, very good, thank you.
Okay, thank you.
Thank you.
Hi, Nisab as well. Thank you very much for your presentation.
Thank you. Thank you so much for your time.
Thank you.
It was absolutely great to have you with us. Thank you for the effort and the time to be with us. Have a good rest of the day, and for that today, that's everything.
Thank you.
Thank you so
Thank
much.
you all so much.
Bye-bye.
Goodbye.
Thank you.
Okay, very good. Let's get ready right now for Gridbrid. It will be Karina from Estonia. Karina. Hello, Karina. Welcome. Great to have you.
Thank you so much. Excited to be here.
That's great to hear, and also want to congratulate you on making this to the top 60 of Free Electrons 2025. We are all here ready to hear more about your solution. We can see your screen. You can start whenever you're ready. We will count 6 minutes for your presentation.
Okay, awesome. Thank you so much. So hi, everyone. Thank you so much for taking the time to listen to my pitch. My name is Karina, and I'm the co-founder of Gridbrid, a software that makes planning complex energy projects simple. So we all know that developing hybrid power plant projects is a very complex, costly, and fragmented process. And Gridbrid addresses that by drastically reducing the complexity, the cost, the risk, and the time required to design, evaluate, and deploy renewable energy projects while improving the project's profitability. Compared to other solutions available in the market, Gridbrid's holistic approach outperforms competitors in 3 main ways. First, we're technology agnostic, so we can model renewables, non-renewables, and storage assets in one platform. Second is our scalability. From small microgrids to utility-scale power plants, Gridbrid is scalable across geographies and stakeholders. And thirdly is our holistic optimization. We co-optimize the technical, financial, and economic layers of every project across thousands of different project scenarios to deliver the very best possible outcome for all stakeholders. Our software makes it simple to co-optimize multiple technologies based on your goals with embedded data like demand generation and price patterns to get your desired results across your feasibility studies, financial due diligence, and supplier contracts. And with a single software, we can help ESB to optimize the planning and deployment of renewable energy resources to reach your renewable energy generation capacity targets by 2030. Gridbrid can provide ESB with a streamlined process for adding renewable energy sources to the grid, while also supporting ESB's decarbonization targets and developing a strategy that is compatible with your existing asset portfolio. We can also help JIRA to become a leader in low carbon energy and scale their hybrid energy solutions in advanced power markets. Specifically in Japan, Gridbrid integrates data for the 10 regions of the Japanese market, including recent ancillary service market moves. For E.ON's portfolio expansion of EV charging stations in particular, Gridbrid allows the designing of the right charging specs, grid connection capacity, and optional on-site battery buffer and renewable energy sources, while also accounting for time-sensitive patterns in changing demand behavior and hourly wholesale price fluctuations. For CLP's need for advanced forecasting to prevent grid overloads, Gridbrid can provide a full digital twin to simulate different energy scenarios before the deployment of projects, and help CLP to make decisions on power plant unit activations and power flows. For Origin, we can help it improve your project viability for your renewable energy portfolio with forecasted revenues and IRR for real project timelines. So Origin can use Gridbrid to enhance your decision-making through our integrated full financial modeling to determine the most cost-effective project configurations to de-risk investments and maximize returns on new power plants. For E2P, Gridbrid can help you to unlock the full potential of your portfolio. With Gridbrid, you can model many assets in batch, compare results across your portfolio with our multi-year simulation over the system's lifetime, including degradation. For Hydro-Quebec's challenge in integrating renewable energy assets into its hydro portfolio, you can use Gridbrid's hybrid energy modeling to optimize the integration of wind, ground, and floating solar with existing hydropower assets to improve the dispatch efficiency and reducing curtailment. Our initial pilot scope would include the use of our SaaS on new hybrid plant project developments, and in the future, use our marketplace to build and our data forecasts to operate new power plants. Gridbrid is already being used by industry leaders like ACEN Renewables and UPC Renewables to optimize their bid for tenders and also for our 3 core benefits. First is our cost savings and efficiency gains, from the reduction in project development timeline, lower engineering costs, and CapEx optimization. Secondly is for our improved sustainability and grid reliability from higher renewable penetration and reduction in curtailment. And lastly, an increase in revenue and profitability from an improved project IRR and ancillary market optimization. So Gridbrid is here to power the energy transition and make it faster, smarter, and more profitable. And I'm excited to build the future of energy together. Thank you.
That's great, Karina. We have some extra time. Let's move right away to questions.
Hi, Karina. Thank you. Thank you for that. This is Joanna from Origin. Congratulations on making it to the top 60 of the program. And I really appreciate that pitch. That was an amazing pitch, and the customization was great. So thank you for that. I've got some very specific questions from our business unit that were very interested in the solution. So I'm just going to read them as slowly as I can. One of the main benefits that stands out to us is the one-stop shop approach. So we're interested to understand if anything is lost by trying to do everything in the one program and any implied simplification. For example, Plexos uses bid stacks as well as network constraints to create price forecasts. Does this use the same input?
So we model the system in a holistic way, and we also integrate the economic layers that you can directly output the results in a full financial model in Excel. So that reduces the number of steps, of manual steps at the interface between softwares. And we don't look as deeply perhaps as, for example, PVCs for the solar system, but by encompassing all the technologies, we have a global model that is superior to just multiple accurate split model.
Okay, thank you. Do you allow forecasting congestion and curtailment?
Yes, it can be embedded if you provide patterns of statistical or fixed patterns of curtailment. It can be included. Yes.
Okay. Do you consider market elasticity or competitive behaviors? For example, do you consider saturation levels of markets and the reducing value of the incremental asset?
So if you're talking about, for example, battery cannibalization and saturation on grid absorption of renewables, our model is more at the project level. So the saturation will be embedded at the level of the load, the available load pattern, and at the price, the price patterns level. So these are inputs to the model. We don't yet, at this level, we don't yet model the entire grid of a country.
Okay, all right. There's a specific question about one of the slides that you sent through in your pitch deck around the hourly time series as inputs into the simulation. Are these, is this data that you create or it has to be provided by us?
Both are possible. We integrate a data library that already has, it's connected to the servers of multiple utility companies in countries that have public data available. We already digest this data and format it so it's directly usable in the software. And if the data is not available from Gridbrid, then you can also provide your own data, or we are also compatible with other softwares like WinPro or other software that can give inputs.
Okay. And is there any constraints around localization that we need to consider? So obviously you've got a very geographically dispersed group of people here. We're in Australia. Is there anything that you need to do to the platform?
We work with Minsur in Peru. We work with Tesla in Japan. We work with ASEN in the Philippines. We work with A3 in Europe. So we have clients using our platform a bit everywhere worldwide. What we do also is if we have very specific demands for very specific rules to be implemented, this can be implemented additionally in the software and can be fine-tuned. Yeah.
And just there's some detail here about an ideal pilot, which I think references a period of 1 year. Is there a maybe a more streamlined approach that we can take to do maybe a quicker pilot?
Sorry, you meant the financial model per year or the simulation? So the simulations is over the project lifetime, so as many years as you want. And at the level of financial modeling, we boil this down to days, weeks, months, years. And the current version that we have that generates the Excel output, if you want to provide the Excel output, that for the Excel export, it's essentially per year at the moment. I don't know if that addresses the question.
Thank you.
Yes, the time is up, although we, just to let you know, we have more questions in the room, but we will make sure to get them to you in a written form, okay? But congratulations on your presentation.
Thank you. It was great talking to you.
It's really great to have you here. Have a good rest of the day. That's it for today. 7 minutes, but very quickly, but you made a great use of that. We will be in touch. Thank you very much. Goodbye. Yes, the time passed very quickly. Don't forget the questions, write them in the chat. And I just wanted to.
Yes, sir.
What was I saying? Chat. No, yes, whoever in the chat, but us in the Excel. We have 2 startups right now, 2 nominations from Innovative Cave, okay, Deep Planet, and then Third Equation. We will start with the Deep Planet. Hello, hi, Krishna. Sushma, sorry. Great to have you. Welcome. Congratulations on making this to the top 60. We are very happy and excited to get to know your solution better. Whenever you're ready, you can share your screen. You will have 6 minutes for the presentation.
Yeah, thank you. Thanks everyone. Thanks Martina for having me. Very excited. I'm sure there's a lot of energy in the room and looking forward to any questions. So I can get started. Hi everyone. I'm Sushma Shankar, co-founder and CEO of Deep Planet. We are an AI-first company with using geospatial data and helping companies of all sizes with predictive technology to manage their assets, build resilience, and drive their sustainability initiatives. We are a team come out of the University of Oxford, so we're actually based in the UK, but have global presence. We have teams across 4 countries. We have conducted over 5 years of research to build proprietary machine learning and foundational models. We're a team of 11 with strong root in diverse industries, as you might see. We come from critical infrastructure, defense, telecoms, machine learning, and space. And yeah, very excited to be here. So as I was mentioning, we're an AI first, started actually quite a few years ago, 5 years ago. Our heritage comes from our origin in applying satellite imagery and computer vision techniques to the agricultural industry initially, where we monitored biodiversity, carbon insets, offsets, regenerative agricultural practices. We have done some early work in critical infrastructure, which has involved methane leak detection, water level and water quality predictions from satellite data, as well as urban city greening and forecasting cloud formation for solar power generation. And these are some of our clients there, as well as our timeline as we've developed over the years. So I'm going to be talking about a few challenge areas that has been highlighted in free electrons, as well as our application or USB applied to that. So with high resolution satellite data, weather and historical data, we've pre-trained our machine learning models, all built in-house. We detect and predict vegetation growth, detect hazard trees, as well as detect individual invasive species. To help companies plan, optimize, and execute on their vegetation management strategies, which essentially in increasing efficiency of pre and post-trim inspections. We also look at classifying wildfire risk and potentially providing risk assessment on different assets, track herbicide efficacy, and other encroachments to the assets. Supposed to be moving the slide here. So our customers say that our machine learning models are quite robust. We have global coverage, providing over 90% accuracy in monitoring for natural capital. So we've done this by automating soil health monitoring, which is soil organic carbon, nutrients, etc. We do habitat surveys and overlay ecosystem services. We help clients assess biodiversity units and potential carbon insets and offsets. So we work widely with supply chain industries, which are making use of the carbon insets and offsets functionality. We baseline soil organic carbon and biodiversity, as I said, to auto-generate some baseline reports. And further to the baseline, we monitor for post-development or regeneration scenarios, thus helping these companies to meet their inset and ESG regulatory compliance goals. So lastly, on the asset monitoring side, we help generate digital twins, which basically helps you give precise views of managing utility assets for on-target planning. Any defective assets, anomalies, etc. We spot, provide alerts by email on our platform through API. All of this generated in real time to help manage the full asset life cycle and also help in network creation timelines where you can understand the lay of the land. So just jumping to what's under the hood. So we, how it works. So our USP is really in the research that we put in for the 5 years in building machine learning models, which is all proprietary. You gather satellite data, high resolution.
Are you listening? Can you put the hands in while you're doing it or no?
Planet, so high resolution and low resolution, 10 meter as well as 3 meter and 0.5 meter resolution satellites. So we have a system which combines, extracts information, models pre-trained on that using ground data as well as historical weather data, and we are able to predict these various different models, being able to predict and provide results on our web platform as well as on our API. So I know there was a point where we were in the spreadsheet that we submitted, there was a pilot scenario, so just putting that together as a reference. So we'd be happy to work out a pilot scenario, and this is how we essentially work with most of our clients when we get started. In this case, some of the areas that we could help is looking at monitoring risk to power lines, looking at obviously vegetation risk, wildfire cause, as well as improving predictive maintenance using the AI technology. We leverage AI to spot defective assets, anomalies, and risks. And last but not the least, to monitor environmental assets given the regulatory compliance and the critical issues growing around it, as well as the opportunities. The pilot plan we've kind of classified as 3 phases. I'll go through this quickly, looking at data integration and partner collaboration. We work closely with the partners to understand the requirements, build out the AI model for deployment and real-time monitoring. And then the last phase being performance evaluation, where we're validating the results and assessing the scalability of it. Resources needed, we would need any ground data potentially there is with the utility, sometimes as well as we gather other environmental data, satellite data for model training. Any support needed in understanding this data, as well as we provide integration of the results via API or dashboard. We put in a rough estimate cost, but happy to discuss further if you have any questions there. I'm actually not sure how much time. I do have some time, I think, but I will wind up. Hopefully, you have some questions. In summary, we are an AI-first startup from Oxford building revolutionary technology in geospatial AI to accurately measure risk. We work with some of the world's largest enterprises, saving them millions of dollars, and we are confident that we can partner with a free electrons utility and deliver operational benefits, as well as help drive long-term sustainability. Very excited. Thank you.
Good. Let's move to question. We only have 3 minutes.
Yeah, I can start. Thank you, Sushma, for the presentation. We don't have a lot of time left, but so let me start with a question, which is to understand if you have already worked on these challenges that you have identified, meaning most of your customers right now seem to be outside the utility space. So do you have projects ongoing with utility companies?
To be honest, we don't have utility companies as customers, but we see ourselves already going wider than the agricultural space, as you can probably see here. So we're looking at critical infrastructure with cities, but not directly with utilities. I'll let you ask your next question.
Okay, thank you. And yes, we also have some questions. So.
How often is the analysis done to detect the anomalies, and how does it cope with countries with lots of cloud cover like Ireland?
Yeah, so we use Sentinel, Sentinel-1, and if you're aware of satellite imagery, so we use radar satellites alongside multispectral satellites. So our system is built such that it extracts information when and depends on which satellite is available, if there's certain cloud coverage, etc. So the system is able to extract information from different combination of satellites. And so about 4 satellites, and it can give you anywhere from a day to up to 15 days, right? So depends on the cloud coverage. And we are in the UK, so we totally understand, like we've dealt with the situation quite a bit in terms of maneuvering around cloud coverage.
In terms of city environments, and I know you do some work around urban city greening. From an electricity network operator, we find it hard to identify sites for new substations. Is there any opportunity, do you think, down the line to use your software and analytics to identify sites and leverage all the geospatial data that might pinpoint good sites for ourselves?
Yeah, so we haven't directly worked with the electric utilities, as I mentioned, but with the geospatial data, yes, we could look at opportunities where it depends on the use case and exactly what the location criteria is. With high resolution, we're looking at a 0.5 meter resolution of satellite imagery. Yes, we would be able to tell, especially in urban cities. It's much more straightforward than forests that we've dealt with before.
Thank you very much. The time is up, although we have more questions here in the room that will get to you in a written form. Sushma, thank you very much for your time, effort to put into this presentation.
Thank you very much.
It was great to have you. Have a good rest of the day, and let's be in touch. Thank you. Please say if there are any other questions, write them in Excel file. And let's get ready for a third equation. Also Innovate UK nominee will be Greg joining us in a moment. That will be the last startup for today. Hi, Paul, Joyce, Greg, Brian, lots of you. Hello.
There are four of us.
That all of you took time to be with us. Welcome to the pitch event and congratulations on making this to the top 60. We are here in the room, more than 30 of us, lots of people online, very eager to get to know your solution. Share your screen. We will be counting 6 minutes on the clock for your presentation. You can start whenever you're ready.
Okay, if I click on share, can you see my screen now?
Yes, we can see it very well.
Okay, good. Thank you very much. Third equation has focused on the core issue that we perceive, which is the carrying capacity of the grid to enable the electrification of energy. We have developed our network exchanger, which is designed to increase the carrying capacity of the grid by up to 20%. And we do that by managing voltage, power factor, phase balancing, harmonics reduction, and these are our 4 core functions. This leads to an increasing efficiency of the grid by reducing energy losses. And we also focus on improving power quality by mitigating voltage fluctuations. Our network exchanger has the 4 main functions I just described, and it operates simultaneously on all 4 phases. So all 3 phases, sorry. So we can enable the integration of more renewable energy by moving power waste generated on one phase onto another, or balancing the power between the phases. That allows the distribution transformer, which is the last one in the grid, to appear as an even load across all 3 phases to the higher voltages in the grid. We provide up to plus or minus 10% voltage regulation, and we can do that independently per feeder. And we operate to a target voltage. So that is slightly different from things like online tap changers, which do a voltage percentage change. We can move up to about 150 amps between phases to balance the balance load. And our power factor correction, given that our device is meant to be connected at the substation, we do that between the load and the substation without having any impact on the higher voltages in the grid. The device is intended to be retrofitted to existing transformers, so we're not a transformer manufacturer. We're an additive to an existing transformer, but we are looking at a integrated transformer for later applications. We also provide lots of data. We measure volts, power, amps, frequency, phase angle, and so on at the distribution transformer. So we can provide as much of that data as we need to the grid. I'll just move on my slide. Our unique selling proposition is that we're the only device that provides 4-in-1 functionality. We're the only device that can do all of this in one device. We are speaking to several OEMs because we understand that utilities like to have multiple sources of our device, and we are looking to license our technology to multiple manufacturers. Our key selling point is the increasing in grid capacity. And we think by our calculations, we can do this by up to 20%. And Paul, our CTO, is currently in Australia working on a project with Monash University, which is funded by Race for 2030 in Australia, a government organization. And we are going to validate that claim. So we're going to do this independently with Monash University. Our device is meant to be retrofitted to existing transformers, and we have recently signed a letter of intent with UK Power Networks in the UK, which covers London, to upgrade 5 existing devices with our new technology to demonstrate the retrofit, the capability, the physical layout, and so on. Most of our technology is around the software and the algorithms. We are not a transformer manufacturer, so we have patented our control algorithms, and we sample data and provide lots of information to utilities around the operation of the network. So we can provide a lot of data to utilities. Our device will also characterize the LV feeder in response to calibrate the response to voltage change. So we are looking to characterize the demand response on every given feeder that's attached to our device to provide the utility with the data, the demand response that is technically capable using our device. It's a statistical analysis, and we think that is fairly comprehensive, and it makes us unique in the world of smart transformers. We have looked at the cost-benefit analysis, and we have used a UK model called Transform. It is a well-established tool that's used in the UK, and we've modeled our device back in 2021 to validate our market proposition. And we used the National Grid steady state or steady progression scenario, and we have calculated using this well-respected tool that we could save the UK economy or the GB economy about $4.2 billion over the next 10 years. We have yet to do the calculation with ESB, our sponsor partner in this program, but we have done a pro rata validation. So we looked at the number of homes as a milestone, and so it's about 10% of the UK number of homes. We recognize that the ESB network is largely rural, outside the major cities, and it's single phase. So we've discounted that by about 50% to give us a value to ESB of doing this. And our calculation is about 200 million of saving over the next 10 years to ESB. Our project looks at installing a multiple number of our device in the ESB network. We're looking to demonstrate the effectiveness of what we're trying to do, and we're looking for real-world validation of our claims. We believe in our technology. We retire technical risk. The device works, but we're looking for real-world applications to take us from TRL 7 to 8. The total cost of the project is about $450,000. All of our numbers are in dollars right now, and We're looking to prove the operation, the device, and the value to ESB in the island of Ireland. The things we need to have. Yeah.
The time is up. I suggest if you would like to leave this slide, but let's move to question. We just have 3 minutes.
Yep.
Hi, it's Kieran here from ESP Networks. Congrats on making it to the top 60 of this year's program. A couple of questions. In relation to capacity, could you just go through how it increases the capacity of the existing distribution assets, or does it in fact unlock the last 20% of capacity through the optimization of voltage, current, etc.?
Okay. The brief answer, Kieran, is that by reducing the thermal load on the transformer, we can increase the capacity. And the second item is by moving the reactive power between the load and the distribution substation, we are not affecting the higher voltages in the grid.
Okay. What's the expected lifespan of the device?
We are working to a design life of 15 years.
How does the device respond during both medium voltage faults and then low voltage faults?
We have not looked at the medium voltage faults, but our device is parallel and series connected to the LV side. In case of failure, our device shuts itself out from the LV circuits. So we are isolating ourselves from the LV faults.
In terms of the monitoring and communication, is that through SCADA or through a connection to the cloud? And can set points be issued remotely? Can the device be turned on or off or disabled or enabled remotely?
I'll ask Paul to answer that.
Yep, so we've designed the system so it doesn't need to be connected. We do see the benefits of having a cloud connected system. So today it is Modbus connected, so it can easily integrate with SCADA. But you can issue set points, but we've designed it so it doesn't need to have that. It will work straight out of the box. But you get benefits from having a connected system.
Perfect. For supplying, I suppose, DSOs or utilities and retrofitting to existing transformers, is the network exchanger supplied as a self-contained module or individual components that we would have to build into our existing pad-mounted substations?
So it's a self-contained module. Yeah.
Sorry, Paul. We both answered the same.
Andre?
Any questions? Paul Andre, yes?
Yes, I'm Paul Levesque from Quebec. A few questions. First of all, your device is available for what voltage levels? I know it's low voltage in the UK, but it means how many volts?
So in terms of operation, it's designed for 300 to 500 volts.
Good, thank you. And in terms of cyber security, is your device designed for cyber security immunity?
It will be. So in terms of our system now, it's Modbus connected, so we're seeing limited communications, but the final version, the one that we'll deploy into the field, will be cyber secure.
Okay, and in terms of low voltage, we're talking a three-phase or one-phase application?
Three-phase.
And is it adaptable to one phase?
Yes, it is, yeah. So in terms of the system, the phases work independently, apart from phase balancing. So we have a solution that works on three phases, but it can be adapted in software to make it a single phase.
Thank you.
Well done. Okay, and then our time is up. Thank you very much, the whole team of Third Equation, for being here with us.
Okay, thank you.
It was great meeting you. Thank you for all the effort and time. We will be in touch, but for now, have a good rest of the day.
Okay, thank you. Bye.
Thank you. Bye.
Yes. Wait, man.
Paul, you can click in the bottom right, there is a button to leave the room, yeah.
Take 10 or 12 minutes, then we'll do the final debate today.
Yes.